All right, this is AP BC Calculus. We're doing a BC only unit. This is Unit 10, Section 7, Alternating Series Test for Convergence. This is super duper useful. Please memorize it. It's really useful for any series that alternates signs. Okay, so the alternating series test for convergence. Suppose you have an infinite series. We're going to use that same summation of a sub n. And you want to know if it converges or diverges. If a sub n is either of the form negative 1 to the n times b sub n, or negative 1 to the n minus 1 times b sub n, where b sub n is a non-negative term. So all that's saying is the series is alternating with, sorry, there's a missing parenthesis, it's going to bug me. All this is saying is that the series is alternating signs, and b sub n is the part of the series that's not alternating, right? It's the part of the term that's not alternating. So if b sub n is decreasing, and if it's trending towards 0, meaning as n approaches infinity, b sub n goes to 0, then by default, a sub n converges. If those things are not true, the test is inconclusive and we're not able to figure anything else out. Okay, so let's revisit the alternating harmonic series. So we know it converges. I told you to memorize it converges. Please, please, please memorize that it converges. But let's go ahead and walk through the alternating series test for convergence. So this is the piece of the series. So this is the piece that says alternating, right? So this is the piece, 1 over n is the piece that is the positive part. So the question is, we have this b is 1 over n. Is it decreasing? Well, yeah, you can see that 1 over n plus 1 should be smaller than 1 over n because a bigger denom means a smaller fraction, right? A bigger denom is a smaller number. So that's true. Yes, it's decreasing, right? You can also figure that out intuitively if you go ahead and plug some numbers in, right? And is the limit as n approaches infinity of 1 over n equal to 0? And the answer is yes, because as you plug in an infinity. So since those two things are true, it has to converge by the alternating series test. That's all you need. You just need to show that the positive term, the b sub n, the thing that's not alternating, is decreasing and approaching 0. If those two things are true, you can say that something has to converge. So go ahead and apply the alternating series test again, right? So in this case, right, so if we were to clean this up, this is a negative 1 to the n minus 1. This is the part that's alternating, right? And a 1 over the square root of n to the third, which is the part, that's my b sub n. That's the positive part of this thing. So number 1, is this thing decreasing, right? And again, you can make the same logical argument, because if you plug in an n plus 1 quantity cubed, that's a bigger number, right? Bigger denom equals a smaller fraction. So this thing is definitely smaller than this thing, because as you plug in a number, so n plus 1 is a bigger number than than just n, so it's going to be a bigger denominator, smaller fraction. So yes, it's decreasing. Second thing is the limit as n approaches infinity of this thing equal to 0. Well, yes, it is, because if you plug an infinity in here, you get a finite number divided by an infinite number, so yes, it is. So by the alternating series test, this thing converges. It's kind of a magic test, because you can just do most of these things in your head. You can say, is this thing decreasing? Is this thing approaching 0? And boom, that's the answer. All right, so we're going to go ahead and try a P1, right? So same thing, you're going to go ahead and realize that this is the alternating piece, right? This is the piece that's doing the alternating, and this is the thing I'm going to call b sub n, right? So is b sub n decreasing? Well, yeah, 1 over n plus 1 squared is smaller than 1 over n squared, right? Same argument, so yes, it is. And is b sub n approaching 0? Well, the limit as n approaches infinity of 1 over n squared is definitely a 0, so that's a yes. So by the alternating series test, this thing converges. All right, let's do an E2. All right, so this one's a little bit trickier, right? So so the answer can be one of the following, and I think I might have actually had this in the top one, but I gave you ones that converged. So either series converges by the alternating series test, alternating series test can't be applied, or the alternating series test is inconclusive, in which case you would just pick a different test, but not in this example, right? So normally you'd pick a different test. So let's look at this thing, right? So here's the negative 1 to the power, right? So this is the piece that's alternating, right? And that means e to the n over root n is my b sub n, okay? Well, the trick is, so there's two things going on. So the question is b sub n decreasing? Well, no. The answer is no, it's not. Because, is this thing, right? So the question is, what's the relationship between this thing and this thing? And the answer is it's not decreasing, and you can actually figure this out pretty quickly. If you're stuck with this, let's say, and the other question is b sub n approaching 0, right? So we can see that one a little bit easier. So as n approaches infinity, is this thing approaching 0, right? And it's not. If you plugged in, you'd get infinity over infinity. If you wanted to clean this up, you could actually try it with L'Hopital's. But the short answer is that exponentials grow very fast. Exponentials grow faster than polynomials, right? In fact, that's why we use the phrase exponential growth in like the pop culture lexicon. Usually means that something has explosive growth, even if mathematically it's not necessarily exponential, right? There's other types of growth, but like the e to the n is growing way faster. So this thing is very much not approaching 0. This thing's actually going to approach something infinitely large. This is huge, right? So this thing is actually growing, right? This is not true. It's growing. And you can see that. Let's say you're having trouble picturing that. There are some other ways to figure that out. But one easy way to do is to just pick a couple n values, right? Like if you picked n as 1, right, you'd get e over root 1, which is just e, right? So that's like 3-ish, right? If you pick n as 2, right, or actually let's make it easier. Let's pick 4 because then we have a square root. I get e to the 4th on top of root 4, which is a 2. That's like an 81 over 2, which is definitely bigger, right? So that's kinda, and it's not really an 81, but it's kind of like in your brain only. That's definitely bigger. And you can see that if you pick the next perfect score. If you pick 9, you're getting an e to the 9th, which is a huge number, right? 3 to the 9th is huge, over a 3, which is not huge, right? So this thing's getting bigger. So when I'm asked which of these things is happening, the answer is I cannot apply the alternating series test. So alternating series test doesn't apply. Now, for the record, this thing definitely diverges. So you weren't actually asked if so this is the answer to this question. But just as a random FYI, sorry, we'll switch colors. Just as an FYI, you were not asked for this. This thing definitely diverges. It actually, so this thing diverges. The easiest way to see that it diverges is by the nth term test, because as you can see, these terms are not going to 0, right? These terms are getting huge. This is definitely divergent, but that's not what you were asked to do in this example. In this example, you were just to say, hey, I can't use the alternating series test because these things are not getting smaller. Okay, same thing with P2, right? Now this one's tricky because you might say, okay, I see the alternating, but what's the other thing, right? What's the B sub n? Well, in this case, if there's no B sub n is just the number 1. So the trick here is that, remember, I have to show two things. I have to show that B sub n is decreasing. Well, it's not. B sub n is literally the number 1. It's always a 1, right? There's no term there. And I have to show that B sub n is approaching 0, but nope. Again, B sub n is straight up a 1, right? It's always a 1. So I cannot apply the alternating series test, right? So cannot apply the alternating series test. And these are kind of weird examples that you're not going to see very often, but I wanted to show you that it doesn't always apply for every alternating series. Interestingly enough, so just a side note as an FYI, you were not asked this. This was not asked. This thing diverges. The reason it diverges is because this is one of those cases where you're going to have, I think it starts at a positive 1. Yep, plug in 1. So it's going to be 1 plus a negative 1 plus a 1 plus a negative 1 plus a 1 plus a negative 1. So this is an oscillating, right? Because we saw this in fact maybe in the first video that the sum of only the first term is a 1, but the sum of the second term would be 1 plus negative 1, which is 0. But then it would oscillate back to 1 because it would be 1 plus negative 1 plus 1, and then it oscillates back to 0, right? 1 plus negative 1 plus 1 plus negative 1 is 0. So the partial sums, right? Partial sums do not approach a single finite number. They do approach finite numbers, approach a single finite number. right? So in order to converge, you have to approach. So you weren't asked that. You were just asked to say the alternating series test doesn't apply, but that's the idea. All right, so when we get to 10.9, we're going to discuss absolute convergence versus conditional convergence, but that'll bring us back to some of the problems we covered in this video. But the basic difference between absolute and conditional convergence is whether the series converges if it were all positive. So when we get to this, we'll talk about, for example, the harmonic series. It's a great example. The harmonic series does not converge, but the alternating harmonic series does. What that means is that the harmonic series converges conditionally, like the alternating harmonic series converges conditionally, right? The harmonic series diverges, the alternating harmonic series converges conditionally because it only converges because it's alternating. It wouldn't converge if it were the regular harmonic series. That's it for 10.7.